All right. Hey, ladies and gentlemen, welcome back. We are going to be solving real life linear inequalities. So the whole idea is that we are going to be like solving real world problems, okay? Hey, we're going to talk about these as a class, okay? Those are going to be in class tomorrow. So we'll look at those in class and we'll talk about those equations. That's going to be our warm-up actually in class tomorrow. So we have the following. Graph the following linear inequalities. Okay, so you can pick. Remember, we have 3 different ways to graph. Okay, do you want to put it in slope-intercept? Is it in slope-intercept? Is it in point-slope? Is it, in standard form for the intercepts? If you want to put it in one of those, make the choice to do that. I encourage you to try this out and figure out what your strategy is. Are you going to make a table? Are you going to put it in slope-intercept? Do you want to graph the intercepts? Okay, I'm going to solve for y since that's what I see 90% of us doing. So I'm going to add 10x. Okay, if you graphed it differently, that's okay. Check your answer. Oops, 10x. So we've got 10x plus 20. Divide by 5. And y is greater than 2x plus 4. Okay, so we're graphing. I can see that the b is 4. Let's begin with the b. So put that on. 1, 2, 3, 4. Oops. Undo. Let's erase that. 4. 1, 2, 3, 4. Okay, and then the m, move with the m. 2 over 1. So I'm going to go up 2 over 1. Up 2 over 1. Okay, so graph that. Is it going to be solid or dashed? Should see that it's dashed. So remember, this is never as good as I would like it to be. Okay, test points. It does not go through 0, 0, so I'm going to try that. Test out 0, 0. So is 0 greater than 0 plus 4? Is 0 greater than 4? False. Remember, that's like a false over here. So everything on that side is false. That means we would shade everything on the other side of the line. All right, try this next one on your own, then we'll chat. Okay, hopefully you pause the video and we can roll on. Okay, so this is not in slope-intercept, but I can get it in slope-intercept by subtracting 7. Y is less than or equal to 3x minus 9. Okay, negative 9 is way down here. Okay, and rise over run. So up 1, 2, 3 over 1. 1, 2, 3 over 1. This is going to be a solid line. Oh, so sloppy. Okay, you know what? I should go a little bit further with that. But all right, does it go through 0, 0? No. Let's test 0, 0. All right, so plug that back into the original. Let's do 0 plus 7 is less than or equal to 0 minus 2. Hopefully you see that 3 times 0 is 0, okay? So is 7 less than or equal to negative 2? That's false. So this side is false. So we're going to shade the other side. Okay. Rocking and rolling on. If you have questions, make sure you pause, you write an arrow, and see where your questions are. I'm going to keep going. Oops. Albert Einstein, how exciting, is selling cups of lemonade at a math conference. He has enough supplies on hand to make a maximum, oh, that's a key word there, to make a maximum of 221 ounces of lemonade. A regular cup holds 10 ounces of lemonade, and a small cup holds 7 ounces of lemonade. Okay, small versus regular. Okay, write an inequality to represent how many of each cup he can make. Okay, hopefully you recognize that there's multiple representations of this, but I'm going to have the regular cups be X and the small cups be Y. So essentially what we have here is we're saying 10, the regular one holds 10 ounces, small one holds 7 ounces, so that would look like this, 10X plus 7, or equal to, so they could get 221. Okay, graph your solution. Oh my goodness. Okay, well this isn't a real great graph. Really I'd say it should be in the positive first quadrant. So let's solve for the y-intercepts. We haven't done that in a while. Let's solve for the y-intercept. So when x equals 0, this whole thing becomes 0, the whole x quantity, and so we have 7y is less than or equal to 221. Okay, using my handy dandy calculator, I divide by 7, and I see y is less than or equal to like 31.6. That's not a great point. Okay, so that's 0, 31.6. Okay, when y equals 0, we get 10x less than or equal to 221. Okay, so again, handy dandy calculator, divide by 10. Oh my goodness, running out of room. X is less than or equal to 22.1. Okay, so this is not a great coordinate grid for this because we have to have the y's go up to 31 and the x's go to 22. So let's go up by, I don't know, 5, 10, 15, 20 along the x's. Let's just go right here. Okay, so I'm going to zoom in. Okay, and let's do 5, 10, 15, 20. Whoops. What number do we need? 22. Okay. 25. Okay. And here, 5, 10, 15, 20, 25, 30, 35. Okay, so for the y-intercept, we can see that right here. The y-intercept is 31.6. So let's plot it right about there. It's not quite accurate. And the x-intercept is 22.1, so right about there. Okay, so drawing our line, it's less than or equal to, so it's a solid line. That was terrible. Much better. Okay, and we want to test a point. Okay, so we got to zoom back out. Okay, zoom back out. Let's test the point. 0, 0. So is 0 plus 0 less than or equal to 221? Well, that's true. So that means all of these numbers are potential solutions. Anything over here. So let's see. Does this match? Can Albert Einstein make 19 regular cups? Okay, so let's go to a different color. 19 regular cups. So that's like right here. And 4 small cups. So if we zoom in, 19 regular, 4 small. So remember, this is our regular here. Regular. These are the smalls over here. So 19 regular, 4 small. That would be like a point right here. Is that part of our solutions? Yeah, looks like it. Here's how we can double check. Let's double check with the equation we had. 10x, so that's these are the x's. These are the y's. So 10 times 19 plus 7 times 4 less than or equal to 221. So we've got 211 less than or equal to 221. Yeah, that's true. So in answer to that, yes, they can. Okay, I'm going to end it there. We'll take a look at the other problems tomorrow, but we're gonna wait until tomorrow to look at that. We're just gonna be doing some problems. So have a great night, and we will see you tomorrow.